All right, let's talk about something that's all around us but almost completely invisible. We're going behind the walls, up into the ceilings, to explore the hidden systems that keep our world running smoothly. Ever wonder how a huge building stays perfectly comfortable, even on the hottest day of the year? Well, we're about to find out. Seriously, think about it. You walk into your office, a mall, any big building, and the air just feels right. It's not too hot, not too cold, not stuffy. That perfect indoor climate is no accident. Nope. It's the work of a massive, complex, and honestly, a pretty fascinating system. And the system responsible for all this magic, it's called HVAC. The best way to think about it is like a building's own respiratory system. It's constantly breathing in, breathing out, and keeping everything inside alive and in perfect balance. So, HVAC, what does that actually stand for? It's heating, ventilation, and air conditioning. And its whole job, its entire reason for being, is to create what engineers call thermal comfort. You know, that just right Goldilocks feeling, and to make sure the air you're breathing is actually clean and fresh.
These three pieces are always working together, kind of like a team. Heating, that's pretty obvious. It warms things up. Air conditioning cools things down. But the real unsung hero here is ventilation. That's the part that's constantly swapping out the old, stale air inside with fresh air from outside. It's a non-stop balancing act.
Okay, so to really get how these systems work, we've got to learn to speak the language. And in the world of HVAC, it all comes down to two really important measurements: how much air you're moving and how much cooling power you've got. The first term you got to know is CFM. That's cubic feet per minute. And it is exactly what it sounds like. It's just a way to measure the volume of air that's being pushed through all those ducts every single minute. The higher the CFM, the more air is on the move. Simple as that. Now this next one is a little weird, but I promise you it's brilliant. It's called a ton of refrigeration, or TR for short. Now this has nothing to do with weight. It's all about cooling power. Get this. 1 TR is the amount of heat it takes to melt 1 ton, a literal ton, of ice over a 24-hour period. What a cool way to think about it, right? And just to put a hard number on that, for all my fellow nerds out there, 1 ton of refrigeration is equal to about 12,000 BTUs per hour. That is a ton of heat, no pun intended, being yanked out of the air every single hour.
So, how does all that cooling actually happen? Well, it starts with these special fluids called refrigerants. They get super cold and they use that to chill water. That chilled water then gets pumped to a big box called an air handling unit, or AHU, and that's where the air blows over cold pipes and gets sent out to you. The newest systems are so smart they can give different rooms totally different temperatures, all at the same time.
Now, as you can imagine, you can't just throw a system this complicated together and hope for the best. No way. It has to follow incredibly strict rules to make sure it works right, lasts a long time, and, most importantly, is safe. Think of these as the official blueprints for performance. And there are two main groups that make these rules. First, you've got SMCNA. Think of them as the Highway Department for Air. They set all the standards for the ducts, the air's roadways. Then you have AHRI. They're like the quality control inspectors for the engine parts, certifying that all the components will actually do what they say they'll do. Right, that's the big question, isn't it? It's one thing to have a rule book, but how do you know the system that's actually being installed, hidden away in the guts of the building, is following those rules?
The answer? You test everything, rigorously. They actually run smoke and light through the ductwork to spot any tiny leaks that would waste energy. They'll test the chemical makeup of the sheet metal itself and even check the thickness of the protective zinc coating to make sure it won't rust away.
And I mean, just look at this level of detail. They aren't just giving it a quick glance. They are doing a full-on chemical analysis, checking for specific elements like carbon and manganese for strength, and others to ensure the quality of the material. This is some serious industrial-grade science. Which brings us to the final and, without a doubt, the most critical part of this whole process. This is where everything, the standards, the measurements, the quality control, it all comes together for the last line of defense: safety. Because look, being comfortable is nice, we all love it, but the absolute #1 non-negotiable job of an HVAC system is to keep people safe, especially in a fire. The last thing you want is for the ductwork to become a superhighway for smoke and flames. This quote is pulled straight from an installation manual, and it's not a suggestion, it's a command. It means every single little hole where a duct passes through a wall has to be sealed up tight with a special fire-rated sealant. No gaps, no excuses, the stakes are just too high.
And this is where it all comes home. This is basically the final exam for the system. An engineer on site goes through a checklist just like this. Are the ducts built to SMA-CNA standards? Check. Did it pass the smoke test? Check. Are the parts AHRI certified? Is that fire sealant everywhere it needs to be? And finally, is it actually delivering the CFM and the TR we designed it for? Check, check, and check.
Wow, okay, we just covered a ton of ground, right? From airflow to safety seals. So what's the big takeaway? What's the one thing you really need to remember from all this?
It's this. That easy, effortless comfort you feel, it's not effortless at all. It is engineered. It's the end result of a super complex system measured precisely in CFM and TR, built to incredibly strict standards, proven with intense testing, and above all else, designed to keep you safe.
So I'll leave you with a little challenge. The next time you walk into a room and think, it feels perfect in here, just for a second, look up. And maybe, just maybe, you'll have a whole new appreciation for that giant, invisible network that's working away, silently, just to keep you comfortable.